Hi guys, so today we are going to start into topic 1 where we're talking about ratios and rates. Today we're going to focus specifically on equivalent ratios. And before we can do that, we really need to talk first about what a ratio is. So a ratio compares two or more numbers. A ratio can be written in 3 different ways. It can be written in words, with a colon, or as a fraction. So for example, we want to write the ratio of squares to triangles, and we can write that in 3 different ways. We have 1 square, and we have 3 triangles. So if we are writing the ratio of squares, that means we write squares first. So 1 to 3 using the word 2, 1 to 3 using a colon, or 1 to 3 written as a fraction. The one thing that we need to focus on is that the order does matter. If squares is written first in the ratio, that means the number of squares comes first and then triangles second. So it is very different if I were to ask for the ratio of triangles to squares, because if I were to ask for triangles to squares, then I would be looking for the ratio of 3 to 1, and those are 2 very different ratios. Now that we know what a ratio is, we want to look at equivalent ratios. So equivalent ratios are ratios that have the same value, okay? So the same value, that means they have the same simplest form. So let's take a look at these ratios that we have here. In this first ratio, I have 2 stars and 1 heart. So we have the ratio of 2 to 1. That's our stars to heart. Now we also have, in this next one, we have 4 stars to 2 hearts. If I simplify this ratio, right, I can divide 4 and 2 both by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. So as we can see, those are the same simplest form. And then this one over here, we have 6 stars and 3 hearts. And again, if I simplify this, I can divide them both by 3. And that's going to give me a ratio of 2 to 1. So each equivalent ratio has the same simplest form. Now, if we want to create our own equivalent ratios, let's say we're starting with the ratio of 3 to 4. I can do one of 2 things with this. I can multiply or divide to find equivalent ratios. In this case, 3 to 4 is already as simple as it can get. So I can multiply both my 3 and my 4 by the same number to create an equivalent ratio. So if I, for example, did 3 times 5 to get 15 and 4 times 5 to get 20, we have the equivalent ratio of 15 to 20. Now, as I said, we can also divide to find equivalent ratios. So if we had the ratio 12 to 8, I can divide both 12 and 8 by 2. Has to be by the same number. 12 divided by 2 is 6. 8 divided by 2 is 4. So now we have the equivalent ratio of 6 to 4. The trick with ratios is to always multiply or divide the numbers by the same value. So if we want an equivalent ratio, we have to multiply or divide by the same value. Okay. So we're going to do some practice. We want to write at least 2 equivalent ratios for each example given. And you can probably come up with more. I mean, you can come up with an unlimited number if we kept going. But we're just going to do 2 examples for each. So starting with 4 to 10, I am going to start by dividing this by 2, because I can divide both 4 and 10 by 2. And if I do that, 4 divided by 2 is 2, and 10 divided by 2 is 5. So 4/10 and 2/5 are equivalent ratios. Now, I can look at 4/10 again, and this time, maybe I want to multiply by 2. So now, instead of dividing, I'm going to multiply both numbers in my ratio by 2. 4 times 2 is 8. 10 times 2 is 20. So another equivalent ratio is 8 to 20. Okay, so now we're looking at the ratio of 12 to 5. I'm going to start by multiplying this one by 2. So if I multiply both numbers by 2, my equivalent ratio is going to be 24 to 10. I can, like I said, I can basically multiply by any number to create an equivalent ratio. So I could also multiply these both by 10. So 12 times 10 would give me 120. And 5 times 10 is 50. So 120 to 50 is also an equivalent ratio. All right, now our last ratio that we want to find equivalent ratios to is 75 to 100. This time the last one we multiplied. This time I want to divide because these numbers are already pretty big, so I want to kind of scale them back and make them smaller. I can divide both 75 and 100 both by 5. If I do 75 divided by 5, I get 15. And if I do 100 divided by 5, I get 20. So 15 to 20 is equivalent to 75 to 100. Another one, if I divide these both by 25, 25 is also a factor of 75 and 100. So 75 divided by 25 is 3, and 100 divided by 25 is 4. So 3 to 4 is also an equivalent ratio to 75 to 100. Go ahead and turn this over to the back. And now we're going to talk about where we would use these equivalent ratios in real life. So in the real world, one place that equivalent ratios come up very often is when we are dealing with recipes and in cooking. So equivalent ratios are used in real life when adjusting a recipe to serve a certain amount of people. So the table below shows the ingredients needed to make Rice Krispie treats. If you notice, it says to fill in the remaining ingredient amounts for the table, we need to follow the next set of directions. We're going to focus on the information we know. We know the full recipe for making 24 squares, right? We see right here, this row, it tells us the full ingredients. But we only know the total servings needed for the other rows in the table. So up here I have that I need 3 tablespoons of butter, 6 cups of cereal, 4 cups of marshmallows, and that makes 24 squares. Okay, I also have that I want to figure out for 12 squares and 36 squares, but I don't have any of the amounts of ingredients. So we're going to actually use equivalent ratios to find this. If we wanted to make only 12 squares, what would we have to do to each of the ingredient amounts? Well, how am I going to get from 24 to 12? Okay, well, if we do 24 divided by 2, that gives us 12. So that's telling me that everything in this row can be divided by 2 to give me the amounts for 12 Rice Krispie squares. So let's look at butter. We have 3 tablespoons of butter, and I want to divide that by 2. If I do 3 divided by 2, that gives me 1.5 or 1.5. So we need 1.5 tablespoons of butter to make 12 squares. Okay. We need, for cereal, we want to do, again, divide by 2. So 6 divided by 2 is going to give us 3 cups of cereal. And then marshmallows, for 24 squares, we need 4 cups. We want to divide that by 2. And then that's going to give us 2 cups of marshmallows that we would need to make 12 squares. All right, so then it says follow through with what was decided in step 2 and fill in the top row of the table. We kind of did that as we went along. So for the next part, it says if we wanted to make 36 squares, what would we have to do to each of the ingredient amounts? So let's look back at this table. I know now how many what the ingredients are for making 12 squares and 24. If we start at the original recipe of 24 squares, I can't multiply 24 by a whole number to get 36. So that's not going to be easy to find equivalent ratios. However, we did scale it back for 12. And I know that from going from 12 to 36, I need to multiply by 3. So 12 times 3 is 36. So that's what we're going to use to figure this out. So I'm going to scroll down so you can see my work down here, but you should have your table filled in for the first 2 rows so you can look back at those amounts when we're working. So if we want to make 36 squares, what would we have to do to each of the ingredient amounts? Well, we are going to multiply our 12 by 3 to get 36. So that also means the amount of butter for making 12 squares, which is 1.5, we are going to multiply that by 3 as well. And we know for multiplying fractions, we're going to change our mixed numbers and whole numbers to improper fractions. So 1 1/2 becomes 3 halves, and 3 becomes 3 over 1. So 3 halves times 3 over 1 is equal to 9 halves. And if we change that back to a mixed number, that's going to give us 4 1/2. So 4 1/2 tablespoons of butter. Now, when we were looking at our table for cereal, we know that for 12 squares, 12 Rice Krispie squares, we needed 3 cups of cereal. So again, we want to multiply by 3. So 3 times 3 is going to give us 9 cups of cereal, and we needed 2 cups of marshmallows. So 2 times 3 is going to give us 6 cups of marshmallows. So now we want to take our amounts and we're going to go back up and fill them into the table. So now for 36 Rice Krispie squares, we need 4 1/2 tablespoons of butter, we need 9 cups of cereal, and we need 6 cups of marshmallows. So again, you can see how we used equivalent ratios to adjust our recipe for either less squares or more. If any of this didn't make sense, or if you were having any problems with this, make sure you raise your hand and ask your teacher. If you need to go back, feel free to go back, look at any part of the notes. If you missed any parts, just go back, pause it, go back, whatever you need to do with this video. But if you have any questions, make sure you check in with your teacher for help.